So we're calculating the present value of a perpetuity. So what is a perpetuity? Perpetuity is a perpetual annuity, an annuity that never goes away. There are two examples of perpetuities that I'm aware of. The one is preferred stock. Preferred stock is a hybrid between common stock and bonds. Historically, preferred stock has not been callable. There actually have been preferred stock issued more recently that is callable, but disregard that. So the other type of investment that is a perpetuity is called a consul, and that, to my knowledge, consuls do not exist in the United States. They are used by European governments. They are bonds that are issued and they stay outstanding perpetually. I honestly don't know if companies use perpetuities or consuls or not. I wouldn't be surprised if they do, but I honestly don't know. So, but the present value of a perpetuity, so if there's a preferred stock, that payment would be the dividend, and R would be the investor's required rate of return. It's a simple calculation. It's actually one of the calculations for some reason that students seem to surprisingly have trouble with, which I don't understand. But anyway, so the present value of perpetuity that pays $100 per year if the rate's 5%. So if the required rate of return is 5%, so 100 divided by 0.05, that's $2,000 is the present value of that perpetuity. If you had a preferred stock that paid you a $100 dividend and your required rate of return were 5%, if we raise the required rate of return to 10%, that present value is going to be cut in half. It's 100 divided by 0.1, so that's 1,000. Next we have a present value of an uneven cash flow. We actually did this calculation previously. When we had it entered in the calculator, but we'll do it again. So we've got $400 next year, $300 in the second year, $250 in the third year. We would present value those all back today. If we divide them by first one by 1.05 to the first power, the second one by 1.05 squared, and the third one divided by 1.05 cubed. So then we add them up and we get 869.02, which is what we got in our calculator. But so next, we have the formula. So the 400 divided by 1.05 plus 300 divided by 1.05 squared plus 250 divided by 1.05 to the third power. Again, $869.02. And the cash flow function, we'll just bring it up in the calculator. Clear, second cash flow, second clear. The information is actually probably still entered in there. I believe it is. So cash flow zero is 0. So C01 is the 400. Enter. C02 is the 300. Enter. Then C03 is the 250. Enter. Another important thing about the cash flow function, it's circular. It goes, so if you use the arrows, so I can go down and check each of those numbers. I can go up and make sure if you get a strange answer, you can look at it and make sure you have it entered it correctly. So then I hit NPV and IS5, so 5 enter, and then down to NPV and hit compute $869.02, which is exactly what we calculated previously. Comparing future value and present value. Future value contains interest, present value does not. So, we saw an opportunity cost rate at 10%, lump sum payment of $700 today is the same as a lump sum payment of $931.70 in the 3 years in the future. That $700 has no interest. That future value of $931.70 contains 3 years of interest. So we go to the next slide. So our first year, our 700, there's no interest. So and then second year, we've got 10% interest, so $70 of interest. The second year, we've got the $70 of interest, and then we've got the year 2 interest is 10% on the 700 and the 70. So that's $147. So the year 3 interest is 10% on the 700, the 70, and the 77. So altogether, that's at $231.70 of interest. So added to the $700 equals $931.70. Solving for interest rates next. So in this example, you pay $78.35 for an investment that promises to pay you $100 in 5 years from today. What rate of return will you earn on your investment? So we're going to use our calculator. So it's 5 years. It's the cost is $78.35. That's a negative. There's no payments, 0 payments. So future value is 100. So then we compute IY and get 5. Let's do it on our calculator. So 5N 78 8.35 plus minus. That's PV, and then 0 payment, and then 100 future value. Then we compute IY and get 5%. So we can also solve for time. As I said, if we have any 4 of the 5, we can solve for the 5th. So we can solve for the rate, we can solve for N, we can solve for the PV, the payment, or the future value. Depends on which 4 we have. So we can solve for time. So this example, the security that costs $68.30 provides a 10% return per year. We want to keep it until it grows to a value of $100. How long we have to keep it? So that's we're solving for N. So 10 IY, the present value is the $68.38 as a negative. There are no payments, 0 payments, and then $100 future value. Compute N. So clear. So we got 10 IY, 68.3 PV, 0 payment, and 100 future value, compute, and we get 4. So, okay. So next we're going to talk about semiannual and other compounding periods. So